Okay, here I am in DCA and different hotel. This is nice. This will be my accommodations for the night. Here's my stuff. This is a really nice hotel. I'll spend the next 20 hours here. Oh, I could do some work here. I'm going to have myself a nice nice lamp and phone, place to work. And I'll show you what the view looks like tomorrow. Got an office building across the way and a balcony. I'll have to check that out. Here it is for the night. Hello everybody, and welcome to the Captain's Log, the Daily Drive. Today, I'm not driving. As you can see, I'm sitting in a hotel room, and I want to give an explanation of why I haven't been communicating over the last couple of weeks. I caught a cold about a month and a half ago, and it wasn't a terrible cold, but it took me a while to feel better. There was a consistent cough. Geez, I was coughing for well over a month after that cold. Felt terrible. I couldn't put two sentences together without hacking, and so making videos was not in the cards. It was not a good route to take. So I've taken a break, and I'm feeling much better. Everything's back to normal, and I'd like to start making videos and share some content with you guys. For those of you that have stuck around, thank you very much. I really appreciate that. There have been a series of events that have occurred over the last month and a half that have really caught everyone's attention. And I'd like to start talking about some of these. For example, that Air India crash in the Dreamliner, the 787. I'd like to have a discussion about that and provide additional feedback. I have a good friend of mine, Patrick, just sent me a preliminary report with the findings, I believe from the NTSB, the National Transportation Safety Board, including some FAA data and other investigated procedures. So I'm going to provide some of that content. I hope you like that. I feel really bad for what has happened. Many people died. I understand there was one survivor, and it's very sad indeed. And there are many questions. At first, I was, I'll tell you off the cuff, without looking at the report yet, there were some things that I was concerned about. There was a lot of speculation because, number one, had not recovered the cockpit voice recorder and had not recovered flight data acquisition units or any of the, computer information that would be readily available, for a download and for investigation. The cockpit voice recorder obviously has some really good information because you can hear what the pilots are saying to each other while things are happening. The black box and the flight data recorder has information that shows the position of switches, the position of flight controls, the airspeed, the altitude, the temperature, everything that's happening that can give you a really good idea of how to assess, how to better assess what was happening at the time. And I will provide my my years of knowledge and understanding to see if we can come up with our own conclusion or a preliminary conclusion, and then I will share what the findings were from the investigation. Off the cuff, I initially speculated because there was a probe that drops from the belly of the aircraft when there's no hydraulic or electrical power being generated, and that probe will spin like a fan, like a generator, and it will provide electricity and hydraulic power to the aircraft. So I'm not really 100% sure how that works because there is not one of those probes is not on the type aircraft that I fly, but I know that is primarily for electrical power, and I'm pretty sure that it will provide electrical power, which will in turn probably run some hydraulic pump that will provide hydraulic power to the aircraft, because those are the two most important things to help keep the aircraft running or operating. But typically that doesn't come out if you have hydraulic or an electrical power. So what made me think that there was a dual engine failure, which is very unlikely for an aircraft this sophisticated. That kind of thing doesn't happen. It's possible to have one engine failure, but it's unlikely to have a dual engine failure. If you have a dual engine failure, it's probably due to fuel starvation or contaminated fuel. Contaminated fuel could be water in the gas accidentally. There could, gas could get into the wing. It's unlikely because the fueling port is under the wing, so the water is not going to go in that way. But if there's a leakage of any type, into the tanks, the water typically is heavier than the fuel, so it would sink to the bottom, and it's probably the part that's going to get sucked in by the pumps, by the scavenging pumps that, just like in your car, that suck gas from the tank into the engine. And this is one of the reasons why you should not, for those of us that are poor at adding gas when you need it, and you let your car get down to the amber light that says low fuel, that's not good. That's not good, because then those pumps on the bottom are sucking any debris, any sediment that's sitting under there, as opposed to sucking the clean fuel. So it could clog your injectors. It could cause damage. It could cause a number of things. But in any case, in this case, the concern is that the fuel was contaminated. It could have been the wrong type of fuel. Airports can fuel an aircraft with we call Jet A, kerosene. It's jet fuel. But there's also 100 low lead, which is like for reciprocating engines, for propeller engines. And you can actually run 100 low lead on your car. I think the highest octane at the gas pump is probably like 92 or 93. So just imagine if you use 100, that's a very high octane for a car, but it would run, it would work. And 100 low lead is also distributed in the airports. I don't know what kind of airport they were taking off in India, what the facilities are like, but it's possible, that they took the wrong fuel truck and fueled the aircraft with the wrong fuel. I don't believe that airplane can fly, and or the engines can operate, and if they do operate, they will operate in very poorly with 100 low lead versus the kerosene. So that was my first inclination, that the fuel contamination, the wrong fuel, which possibly could be the only thing in my mind other than terrorist activity that would cause both engines to quit at a similar time. I think that they may have stopped working around the same time within a second or two of each other. So it was something that happened pretty much simultaneously. So whatever affected one affected the other. There was speculation whether they had flown through a flock of birds, kind of like the U.S. aircraft with Sully and the Hudson. They flew, as they were climbing out, they ingested a flock of birds, which destroyed the engine. Sometimes a flock of geese, those birds are 15 pounds. Can you imagine? 10 of those birds just getting ingested into the engine. It would be terrible. Even small birds could cause a lot of damage. But there was no evidence of birds at the airport. Nothing like that was reported, and there was no evidence of that I could see. Let's see. So those were my preliminary assumptions based on only seeing an aircraft taken off and then shortly thereafter descending and coming to a crash. So I'm going to get right into it, and I'm going to start showing you some additional data, and I'm going to show you some of the findings that they've come up with for this investigation. So please hit subscribe, stick with me. There's going to be a few more videos associated with this. I'll do the best I can to share what I have. Thank you. This is a preliminary report. It's an accident involving Air India's Boeing 787-800 aircraft bearing registration VTANB at Ahmedabad on June 12, 2025. This document has been prepared based on preliminary facts and evidence collected during the investigation. The information is preliminary and subject to change. In accordance with Annex 13 to the Convention on International Civil Aviation and Rule 3 of Aircraft Investigation and Accidents, Rules 2017, and sole objective of the investigation of an incident shall be to prevent accidents and incidents and not to apportion blame or liability. The investigation conducted in accordance with provisions of the said rules shall be separate from any judicial or administrative proceedings to apportion blame or liability. Consequently, the use of the report for any purpose other than for the prevention of future accidents or incidents could lead to erroneous interpretations. This is the purpose of this preliminary investigation. It's not to blame the pilots. It's not to find blame. It's looking for solutions and to have future preventive measures to prevent any errors that could have led to this tragedy. Here are the facts that we have at the moment. On June 12, 2025, there was a crash of Air India's Boeing 787 aircraft. It was flying from Ahmedabad to Gatwick and crashed at about 8:09 UTC immediately after takeoff. And the notification was received from the Airport Authority of India and the airline operator. On receipt of the notification, a team of 5 officers from the AAIB, including DG AAIB, reached Ahmedabad on the same day. Another 3 officers from the Air Safety Directorate arrived from Mumbai to assist in the accident site. Activities were put up at disposal of the DG and AAIB. Okay, the efforts of the site were led by the DG and AAIB, and evidence collected and other site activities were carried out. The initial notification of accident as per ICAO Annex 13 was sent to National Transportation Safety Board in the USA, which represented the state of design and manufacturer. It's a Boeing 787. And as per the information notified to AAIB, the fatalities among passengers also includes citizens from the United Kingdom, Portugal, and Canada. The initial notification of the accident as per ICAO Annex 13 also sent the AAIB in UK, Portugal, and the GPIAAF Portugal and Transportation Safety Board TSB Canada, which represented the other states whose citizens suffered fatalities in the accident. The NTSB USA appointed an accredited representative and technical advisors from Boeing, General Electric, GE, and the Federal Aviation Administration to assist the investigation. A team led by the NTSB accredited representative comprising of representatives from Boeing, GE, and the FAA arrived at Ahmedabad at about 15/6/25. So that would be June 15th, 2025, and participated in the investigation. A team of officials from the AAIB and UK also arrived at Ahmedabad and visited the site with DG and AAIB. The AAIB, the DG AAIB, in excess of power conferred to him by the Rule 11.1 of the Aircraft Investigation of Accidents and Incidents, Rule 2017, appointed investigation team comprised of Mr. Sanjay Kumar Singh as investigator in charge, and Mr. Jasper Singh Larga as chief investigator, and Mr. Vipin Venu Varako and Mr. Viraragavan K and Mr. Vaishnav and Vijay Kumar as investigators. Experienced pilots, engineers, and aviation medicine specialists, aviation psychologists, and flight recorder specialists have taken on board as subject matters to assist the investigation in the same area of their domain expertise. Okay, so we had, we had a total of 12 crew members. The fatalities included a total of 12 crew members, 229 passengers, and 19 others. I'm assuming that the 19 others were persons on the ground, unfortunately. Fatalities, and then serious injuries. They had one passenger with serious injury. I believe that would be the survivor. And then 67 others had serious injuries as well. So I'm thinking maybe those were people on the ground. This was a Boeing 787 Dreamliner. It was manufactured in 2013, and the owner of the aircraft is Air India Limited. Okay. Let's see. It has a lot of additional useful information here. The total aircraft hours, 41,868 hours. So it's flown quite a bit. It was in airworthy condition, and it has here all the information. Total engine hours and cycles, 33,439 hours, and 6,202 cycles. Let's see. It talks about the line maintenance and all of the maintenance that the aircraft had undergone leading up to this event. Says that the last major line maintenance check, as per the aircraft maintenance program, was an L1-1 and L1-2 check carried out at 38,504 hours and 7,255 cycles. The next major check, the D check, was due on the aircraft on December of 2025, which would be later this year. The left engine was installed in May of 2025. The right engine was installed on March of 2025. There were a couple of MELs. I'm looking through the MELs right now, and I'm looking at anything that would have, been pertinent to this. Flight deck door, visual surveillance, airport map function, core network, printer. An MEL is minimum equipment list, and these are the items that are deferred. They're not necessary for the flight, so anytime that there is a maintenance issue, that can be deferred for a later date. There are different types of MELs. Some items cannot be deferred, so they have to be repaired right away. Some items must be fixed within 72 hours, 24 hours, 10 days, 120 days, so on and so forth. So that is all specific to the airlines and their operating agreement with the FAA. So what may be allowed for one airline may not be allowed for another airline. In this case, let's see, all applicable airworthiness directives and alert service bulletins were complied with on the aircraft as well as the engines. So the aircraft was airworthy, everything was complied with and was up to date. The FAA issued special airworthiness information bulletin on December 17, 18 regarding potential disengagement of the fuel control switch locking feature. This SAIB was issued based on reports from operators of Model 737 airplanes that fuel control switches were installed with the locking feature disengaged. The airworthiness concern was not considered an unsafe condition and would warrant Airworthiness Directive AD by the FAA. The fuel control switch design, including the locking feature, is similar on various Boeing airplane models, including, fitted with the 787-800 variant. As per the information from Air India, the suggested inspections were not carried out as the SAIB was advisory and not mandatory. The scrutiny of maintenance records revealed that the throttle control model was replaced on this aircraft in 2019 and 2023. However, the reason for the replacement was not linked to the fuel control switch, and there has been no defect reported pertaining to the fuel control switch since 2023. The damages that occurred was the aircraft was destroyed due to impacting several buildings with the buildings on the ground and subsequently a fire. A total of 5 buildings shown in the figure below were impacted and suffered major structural and fire damages. So here's some pictures. Take a look at this. This is a picture of the airport, and oh, that's not good. Here's some pictures of on the ground. On the left-hand side, you see the runway, and on the right-hand side, you see the yellow circle, and that is showing you the buildings prior to being impacted. And then this is what the buildings look like after being impacted. Here's a picture that shows the buildings, and it shows the different aircraft parts. I see the right wing, center tank, left-hand wing, nose landing gear, vertical stabilizer, the right engine, the right wing. Tail section. Here's the tail section, the wrap probe. It's a very detailed picture. The wreckage and the impact. After takeoff, the aircraft impacted the BJ Medical College Hostel, which is like 0.9 miles, nautical miles from the departure end of runway 23. And the ELT, emergency locator transmitter, was not activated during this event. The wreckage from the first impact point till the last identified aircraft item was distributed in an area of approximately 1,000 feet by 400 feet. A layout of the crash site has been given. That's the figure that I just showed you, where it shows where all the different aircraft parts were on the ground, indicating significant parts of the aircraft. The buildings at the wreckage site have been labeled alphabetically A through F in the layout for easy reference. Okay. As the aircraft was losing altitude, it initially made contact with a series of trees and incineration chimney inside the Army Medical Corps compound before impacting the northeast wall of the building. And the distance between the tree on which the aircraft made its initial contact and the point of building A, where the aircraft impacted, is only 293 feet. Okay. As the aircraft was moving forward, it continued fragmenting and collided with other structures and vegetation. The impact marks on the building and airplane indicate a likely nose-up attitude of about 8 degrees, which makes sense because the aircraft is, it was in a climb out, so when the engines lost power, the first thing that I would think that pilots would do is try to maintain altitude by bringing the nose up. So instead of the airplane flying like this, it's probably going to be at a little bit of an angle. Maybe as it's losing speed, they're lowering the nose to try to regain some of that speed. Here's a picture to show you what that angle would have looked like, about an 8-degree angle. So here it is, and I know I'm reading off of a report, but this is a very technical report, and so I'm doing the best I can to relay it to you. This is exactly the way it came from the ICAO investigation. So here is the tail of the aircraft, okay, as it's impacting the building, and this is the angle that the aircraft was in as it was descending. This is the tail of that building. So what you see right here is this right here. As the airplane continued its path across the roof of the building, the right engine struck the concrete water tank structure and rested underneath the water tank structure, facing a heading of approximately 226 degrees near southwest wall of building A. The inboard parts of the right wing were found in buildings A and B and around areas surrounding the building. Okay, that is the right-hand wing, outboard wing. This is the left-hand engine. Oh my gosh, that really struck that building hard. And here's the nose landing gear. The landing gear lever. This is down, extended, and this is up. So it was down. This is the lever here. The landing gear lever was down. As I would imagine, they realized they were going to be impacting, and the best they could do is lower that gear for maximum protection. For the pilots looking, here's the flap handle, and I'm not sure what flap position that is in, but that's going to be an area of concern. We need to know if there were flaps extended, or if part of the reason they crashed or were not able to sustain altitude was because the flaps and slats were not extended, and maybe the aircraft stalled. I don't know if 8 degrees is enough to cause that aircraft to stall. I don't think so. This is a normal throttle quadrant, okay? These are the fuel switches, okay? Fuel control switch, very similar to the 737 MAX. Typically, there is a locking mechanism right here which prevents those switches from being turned off. If they're turned off, that cuts the fuel to the engine and causes the engines to shut down. Here are the switches, and it's very difficult to see if they're on or off. So you're seeing what I'm seeing. This is very important. It says the thrust lever quadrant sustains significant thermal damage. Both thrust levers were found near idle, the idle position. However, the EAFR data reveal that the thrust levers remain forward in takeoff thrust until the impact. Both fuel control switches were found in the run position. So I would imagine that this preliminary investigation, you know, every pilot asks, well, if it wasn't fuel starvation, if there wasn't something catastrophic like they ingested birds or another animal on the runway that could have caused the engines to fail, then what could it have been? Could it be that the pilots inadvertently turned off the fuel control switch accidentally or in some other way? I don't know. It's difficult to speculate that because at the moment this is not, you know, that I'm aware of, they're not considering terrorism or sabotage of any type. Okay, so the investigation revealed that the fuel control switches were in the on position. So keep that in mind. That's a very important fact to remember. Let's see what else it says here. It talks about the pilots. The captain was an ATPL license holder, and he was 56 years old. And then the co-pilot was a commercial pilot license holder, and he was 32 years old. Flying experience. Let's see, the captain had a total experience of over 15,000 hours. That's a significant amount of hours. And the co-pilot had 3,400 hours. See, total flying experience in this aircraft, the captain had 8,596 hours, and the co-pilot had 1,128 hours. Also significant experience from both pilots. The total flying experience as pilot in command on the type for the captain was 8,260. That's an extraordinary amount of time in that airplane. And then the co-pilot had 0 hours as pilot in command because he hasn't made captain yet. But he's got 1,128 hours, which is a significant amount also. Within the last 180 days, each pilot had flown over 200 hours. The captain had 262 hours. The co-pilot had 233 hours. And similar experience in the last 30 days, 60 hours. Okay. The meteorological conditions, let's see. According to this, temperature was around 36 degrees. Visibility was 6,000 meters, and the winds were 240 degrees at 6 knots. Nothing out of the ordinary, fairly routine day. And let's see what else. It's an asphalt runway, 3,505 meters long, pretty significant size runway. Let's see what else of significant. Okay, so here we go into the flight recorders. So this is the part that everybody wants to know about. The aircraft is equipped with 2 enhanced airborne flight recorders, let's see, the EAFR are fitted at 2 locations. One is in the tail section, and the other one is in the forward section of the aircraft. They're similar construction and record a combined data stream of digital data and cockpit voice information, and both stored at the same time. So let's see, the EAFR receives electrical power from the aircraft's main electrical system, and then the forward EAFR contains an additional power source from the recorder independent power supply, a system that provides electrical power to the forward EAFR in the event of power or a bus loss on the aircraft. This allows the forward EAFR to continue to record available digital flight data and voice data from the cockpit area microphone, even after power is lost to other systems. So I'm going to show you a picture of the aft and the forward EAFR. Okay, according to this, it says that the EAFR one was located on a rooftop and had been badly burnt, as you can see. And then the other one was covered in soot, but was still attached to the aircraft. Let's see. You know, I've got poor video equipment. I'm still trying to figure all this out. So I really appreciate you guys putting up with it. I'm just trying to give you the facts and give you my opinion on this as well, at least my professional opinion based on what I'm reading. I wasn't there investigating, so I don't know what happened. I don't know. I don't have any details other than the details that I get from the news and the detail that I'm getting from these preliminary reports. And as I get more information from the NTSB or the FAA, then I will share it with you. Let's see here. Okay, it says here, let's see. Okay, it's talking about the flight was originating at Ahmedabad to Gatwick. It was operating by the crew, and it gives their credentials. It says the crew arrived at the airport and underwent a pre-flight breath analyzer test and were found to be fit to operate the flight. That's interesting because that is not something that's typically done here in the U.S. When we arrive at the airport, now we can be randomly tested at any time. You can arrive at the airport, and it happens, and you may be asked to have conducted a breathalyzer test in a secured area with, a physician administering that, so that there's no mistake or accident in the reporting of it. Or if you're suspected to have to be under the influence of anything. In this case, it sounds like they either did something like that, or they do it as a standard practice. So the crew had undergone a breathalyzer test and were found fit to operate the flight. There were 230 passengers on board, out of which 15 passengers were in business class and 215 passengers were in economy class, including 2 infants. 54,200 kilograms of fuel. Okay. Gives you more specific data like that. Gives you the airspeeds for the pilots out there. V1 was 153 knots, VR was 155, and V2 was 162. Those are pretty fast speeds. Let's see what else. Okay, it says that in the cockpit voice recording, well, let's go back. It says the aircraft achieved the maximum recorded speed of 180 knots at about 8:08 UTC, and immediately thereafter, the engine number one and engine number 2 fuel cutoff switches transition from run to cutoff. That's odd. Position one after the other with a time gap of 1 second. The engine N1 and N2 began to decrease, as would be normal because you're cutting the fuel. You're basically manually shutting down the engines. I don't know what could have caused that. I don't know what could have happened for them to possibly manually turn off an engine. I can't think of anything, and there are no checklists that I'm aware of that would instruct a pilot to shut the fuel to an engine at a couple hundred feet above the ground. I don't understand that. So let's see, the engine 1 and 2 began to decrease from their takeoff values as the fuel supply to the engines was cut off. In the cockpit voice recording, one of the pilots is heard asking the other pilot, why did he cut off the fuel? That is a very good question. I can imagine that is a critical moment at just a few hundred feet above the ground, and one pilot reaches over and cuts the fuel off to the engine. The other pilot's gonna say, why did you do that? Why'd you cut off the fuel? And let's see. So that was in the cockpit voice recorder. It says the footage obtained from the airport showed the ram air turbine getting deployed during the initial climb after liftoff. No significant bird activity is observed in the vicinity of the flight path, and the aircraft started to lose altitude before crossing the airport perimeter wall. So this was really low to the ground. As per the EAFR data, both engines' N2 values passed below minimum idle speed, and the rat hydraulic pump began supplying hydraulic power at about 8 o'clock. So this is how close to the ground, the aircraft was. It was just on the takeoff. And here's the rat probe being deployed. That little guy, that little fan, is going to provide the hydraulic power that the aircraft needs to raise and lower the gear or operate flight controls. Okay, as per the EAFR, the number one fuel cutoff switch transitioned from cutoff to run at about 8:08 UTC. The APU inlet door began opening, consistent with the APU auto start logic. Thereafter, at about 8:08:56, the number two fuel cutoff switch also transitions from cutoff to run. Okay, when the fuel control switches are moved from cutoff to run while the aircraft is in flight, each engine's full authority dual engine control, the FADEC, automatically manages a relight and thrust recovery sequence of ignition and fuel introduction. I can tell you that that is not a quick relight. These engines take time. You know, these are very complex, very large engines, and the sequencing and the timing internally in the engine, you know, gauging the fuel has to be just right, because you don't, you know, the system is set up to avoid a fire or, you know, damaging the internal parts of the engine. So, for example, never had to do a relight like this in flight, but I can tell you that these large engines takes about 3 minutes to start. And 3 minutes may not seem like a lot of time, but I can tell you that in 3 minutes, I could leave a gate and taxi an airplane a half a mile away. That's 3 minutes. That can happen in 3 minutes. That's, you know, moving around at 15, 20, 25, 30 knots on the ground. Okay. I know it takes about 3 minutes to start the MAX, the 737 MAX engine, and then we have a requirement to operate it for 3 minutes for a warm-up before we can even apply takeoff power. But in this case, it says that the EGT was observed to be rising for both engines, indicating a relight. Engine 1's core deceleration stopped, reversed, and started to progress to recovery. Engine 2 was able to relight but not arrest core speed deceleration, and reintroduced fuel repeatedly to increase core speed acceleration and recovery. The EAFR stopped recording at 8:09. At about 8:09, one of the pilots transmitted, "Mayday, mayday, mayday." The ATCO inquired about the call sign. ATCO did not get any response, but observed the aircraft crashing outside the airport boundary and activating the emergency response. Crash fire tender left the airport premises for rescue and firefighting, and they were joined by fire and rescue services from the local administration. Okay. The last items that it talks about here is the wreckage site activities. See, both engines were retrieved. Components of interest for further examinations have been identified and quarantined. Fuel samples were taken from the Bowsers and tanks used to refuel the aircraft, were tested at the DGCA's lab and found satisfactory. It was not fuel contamination. Very limited amount of fuel samples could be retrieved from the APU filter and refuel jettison valve of the left wing. The testing of these samples will be done at a suitable facility capable of carrying out the test with limited available quantity. The EAFR data downloaded from the forward EAFR is being analyzed in detail. A statement of the witness and the surviving passenger have been obtained by the investigators. A complete analysis of post-mortem reports of the crew and the passengers are being undertaken to corroborate aeromedical findings with the engineering appreciation. Additional details are being gathered based on the initial leads. At this stage of the investigation, there are no recommended actions to the Boeing 787 and or GE NX-1B engine operators and manufacturers. Investigation is continued, and the investigation team will review and examine additional evidence, records, information that is being sought by the stakeholders. That is a disturbing fact. The part about the fuel switches position. The fuel switches position having been, the fuel control switches having been in the cutoff. I don't understand that. It's possible that in those final moments, I'm not sure if that's, I was going to say it's possible that in the final moments, they've tried everything and, in a momentary lapse of reason, maybe took the fuel switches to off and then back on, thinking that, that would relight an engine. But I guess I'm making the assumption that at this point, the engine had already failed. And I'm not sure if the fuel cutoff is what actually caused the engine to lose power. I believe that's what happened. I believe that they cut the fuel. I cannot understand why they would turn off both engines. Doesn't make sense. Turned off both engines, the airplane began to descend, and they were not able to relight the engines, and the engine crashed. The big question now is why they cut the fuel. Why did they turn the fuel control switch to cut off? That is a question for the investigators. And I will await the answer on that. I'm interested to know what could have led them to that. So I hope that you liked my assessment. I hope that you liked my comments. I'm sorry I'm reading off of a prompter here, but this is a technical report and I'm trying to give you as much information as I possibly can. So I would appreciate you hitting subscribe and follow me along and listen to more of the stuff that I'll be covering down the road. Thank you for joining us. Take care.